All right, hi guys. We are looking at solving for each of these quadratics, and in all of these problems you have both an x squared and an x. And anytime you have an x squared and x, you really have three options. You have either factoring, you have quadratic formula, or you have completing a square. So real quick, why don't we even have completing a square as an option here? This one is odd, so it's just not very nice. It's much easier just to use quadratic formula. We have a coefficient, an a coefficient, a, all of those are greater than 1. So since you have that, there's a number out in front here, or this number is odd, you really don't want to use the completing the square. So our two real options are factoring, quadratic formula, which means that in each one of these, what I need to do is see if it is factorable. If it is, just do it. If not, go ahead and do the quadratic formula. So I have written down here, I'm going to do 4, 5, and 6 for you. So for number 4, to do this particular problem, before you factor it, my Algebra 1 teacher always used to say, you need to set it equal to happy 0. And then look, it just makes your whole thing brighter. So I moved that over to make it equal to happy 0. Once it's equal to happy 0, now I'm going to go ahead and deal with that. Multiply the front and the back. I get 6 on the top, negative 6 on the bottom. And nothing works, because 6 and 1 doesn't work, and 2 and 3 doesn't work, so it's not factorable. Which means I need to use quadratic formula. So I have negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have 36 minus, what is this, 12 times 2 is negative 24. So 36 minus 24 is 12. Now, I know that it is tempting to cancel these out, but you cannot. It has to go to both. And you can't deal with this unless there's something that we can pull out of the square root. So the square root of 12 can be rewritten as 4 and 3. So the square root of 4 is really 2. The square root of 3 is the square root of 3. And now you do have a couple options. So you can just straight up distribute both of those. So you have 6 over 6. Whoa, just kidding. And you would get 1 plus or minus. That reduces root 3 over 3. That is one option. Your other option is to find out a number that goes into all three of these. And 2 goes into all three of these, leaving you with 3 and root 3 and 3. Those are actually the same answer, because if I got a common denominator of 3, I would have to multiply by 3 over 3, and I would get the same answer there. Either one of those is fine. So whichever one you feel more comfortable with, just do it. All right, let's check out 5. 5, again, we need to set it equal to happy 0. And, oh, don't forget the happy. Then we use our quadratic formula, our diamond problem. We have a negative 9 and 8. So 9 and 1, that will do it. Now, because this is not a 1, you cannot be diamond and done. Do you like that little rhyme? I have it for you. So what I do need to do is use these to rewrite. So if I have a number in front here, I gotta just do it. We'll do a 9, because I like the 9 with 3. And minus x. It does not matter which order, it will work out. So either way that makes you happy, we're good. Now that we've rewritten it, I factor by grouping, so I have a 3 and an x that can be pulled out. I'm left with just x plus 3. I can pull out a negative 1, and now I also have x plus 3. Woohoo! Here is one of my factors. And leftover. I love leftovers. They're so nice. It means I don't have to make dinner. Oh, the perils of being an adult. So we then set this little dude equal to 0, and we set this little dude equal to 0, so you get x equals negative 3, and x is equal to 1/3. Those are our two answers. So I'm sorry, I didn't write the method. The method here was quadratic formula. The method here is factoring. All right, we have one more to do in this section, so bear with. Again, you have an x squared and an x, which means you need to set it equal to happy 0. Whoa, you know what I need to do? I need to put it in the correct order. There we go. Now we have it equal to happy 0, and it's in happy order. And we see if it's factorable. You do what? 72 and 12. So factors of 72, 1 and 72, 2 and 36, 3 and, I don't know, 72 divided by 3 is 24. No. 4 to 72 divided by 4. Yeah. 4 and 18. Man, we're still not there. 5 doesn't go in. 6 and 7. 12 divided by 6. Whoops, sorry, just kidding. 72 divided by 6 is 12. Yes, 6 and 12. Wow, those are just not. So these were all too far away. These are now too close. So absolutely not factorable. Ding dang it. So now we will use the quadratic formula. So for the quadratic formula, we negative b plus or minus the square root of b squared minus 4ac all over 2a. I just sang that song for you. Isn't that just lovely? So we have negative 12 plus or minus the square root of 144. Let's see. 4 times 2 times 36. I don't know. My calculator says 288. 288. 144 minus 288. So that is 288 is negative 144. So we have negative 12 plus or minus 4. The square root of 144 is 12, but the square root of a negative is I. So 4 goes into both, yeah? So negative 3 plus or minus 3i when I divide both. And that is it, ladies and gents. So my formula was quadratic formula. And I get negative 3 plus or minus 3i. Thanks for playing.